Hello, everyone, and a very warm welcome to today's webinar on harmonizing virtual validation, a seamless blend of design and innovation for the industrial machinery. I'm Clinton, and I'm the marketing manager at SIMTEK, and I'm thrilled to see so many of you joining us today. In the dynamic world of modern engineering and design, the capability to precisely model and simulate intricate scenarios has become a fundamental requirement. From streamlining operational workflows and forecasting market dynamics to advanced product innovation, simulation driven modeling offers critical insights. These insights empower engineers and decision makers to identify the optimal solutions, reduce risk, and enhance overall performance across diverse industries. We have assembled a fantastic webinar, and I am very happy to welcome our guest speaker today. It's my pleasure to introduce Mr. Saravanan. Mr. Saravanan is a senior simulation manager at SIM Technologies and a recognized expert in the field of simulation and analysis. Today, he will be sharing his insights on the webinar topic. Mr. Saravanan, the floor is yours.
Yeah, thank you, Clinton. So we are seeing about the title with the integrated design and the simulation. So what we will do in this modeling as well as in simulation. So in this world, we see wherever the miraculous becomes a commonplace very quickly. How can any company maintain a spirit of transformation year after year? The answer is simulation-based innovation, design, and manufacturing. So this is a major thing we are looking at. At Dassault Systems, we driving the solutions to trend of today's and tomorrow, and right from 5G to electrification to urban air mobility, to communications, to smart factories, to personalized healthcare. So these segments, we are looking into this. So once get into that, so the journey and the 3D experience platform will show about this. So what it means. So to achieve this holistic approach is needed, that including electromagnetics and material science. So we see about the fluid structures and simulation with other technologies. So SIMULIA, along with other Dassault System brands such as SolidWorks, CATIA, Delmia, BioVia, are working together to deliver new solutions related to the shared data from the 3D experience platform. So when we see about this, what are the kinds of applications will gather into this? Like transforming the product innovation process. This can be achieved through the cloud-based, fully connected end-to-end solutions on the collaborative environment of 3D experience platform. So this bringing all the disciplines and stakeholders together from design and engineering, like simulation, manufacturing, governance, and marketing and sales. So today's agenda is follows with this. So how it will be integrated with you, and what are the CAD, CAE associative and advanced simulations, what we are talking for collaborations, and how it is going to be connected also can be seen in this. So 3D experience in this CAD PLM embedded simulation, helping to accelerate the product innovation in a collaborative environment. Through these presentations, I will cover these key values in the context of 3D experience platform, including integration, design-centric user interface, comprehensive capabilities, cloud, scalability, and collaborative environment. Let's talk about the agenda. So we can have a look. So what are the industry challenges and trends, and then what SIM journey at resume, and then key takeaways. So what are the industry challenges and trends? So we have some key KPIs in the equipment industry. When you see about this, the product failure or warranty cost are roughly about 1.5%. So what it will be, take it to the revenue, that's about the hoping of $2 billion in this industry. Product field failures and loss of margins, thereby it's 0.01% of market share, that can be in the tune of millions of dollars. So industrial equipment manufacturers make some of the most complex products in the world under highly competitive market conditions. The primary business KPI here is reducing the cost and time when it comes to a product design and validation. So products are specialized, and then it will be given in the loss of market share. But how to reduce these things, and what are the explorations on products are specialized with the demanding the design and production requirements. So manufacturers face the challenges of creating products that meet customer different performances, like customer performances and the safety requirements, while improving the cycle times and reducing the cost. So time consuming simulation, building models, and requires unique skills and expertise where there is a shortages in this industry. So with all this, we'll go for the key market drivers. So how we will address this challenges smartly in the design and simulation space. So using the ModSim concept. So Revolution is the top international company, manufacturer of a Limapero, and makes underground drilling machine and related equipment that provides a better and more cost-effective alternative to the usage of traditional drilling rigs for mining and tunneling applications. ModSim is a short for modeling and simulation, and it incorporates a workflow that is wrapped around to the tools to help streamline and make the design engineering process more complete. And it is being showcased the approach of the Revolution model. We will be submodeling apart from the leading mining equipment of Bolter 777D, which will illustrate the ModSim workflow. Here's the roadmap. So we'll see that one by one, how it goes to functionate. Let's start with the unique values. We deliver that 3D experience platform for digital transformation. We will demonstrate the ModSim approach in more detail with the workflow that is being used by the SolidWorks customer, Revolution. So this is the traditional modeling, and we are moving into the ModSim. So we'll break down the modeling and simulation process into how a simulation engineer would do a comprehensive and advanced simulation of the entire boom assembly as shown, and provide a feedback to the designer to make a design changes as per the KPI requirements. That design engineer will focus would also be in the some basic level simulation to hone that better design. So the designer focus will be on the design iterations and optimal design, and the product engineer will focus on the advanced simulation and comprehensive simulation. We can see that unique values of the transformation. So what we are seeing in this, it's both side of SolidWorks, and throughout the process, we'll see that handshake between the SolidWorks and the 3D experience. And simulation rules in that. Specifically, we showcase about that truly leverage of power of 3D experience platform to drive the project requirements with the KPI, and what are the values it can give you in the summary point of view. It's a streamlined product process, seamless transfer of SolidWorks and 3D experience, and efficient workflow on this. So this will help you to give an automatic design change. So this simulation drives the challenges with the design process. So what are the things we will come across will be showcased over here. So the modern era of this simulation part will be seen in this. So the typical installation of a SolidWorks, which will be doing the cloud computing. So I'm not showcasing on too much on this installation process, but still there is a link how it will be take it through the launching the app by using these options. Typically, a standard in a SolidWorks installation, the cloud IT will deploy the SolidWorks software on the user machine, or a user can administrator can install this software. So most of the SolidWorks users will have the SolidWorks installations in the dashboard, and the cloud apps will be accessible with the compass in the dashboard. User then searches the Design with SolidWorks app and complete the cloud side installation. So, which is a intuitive cloud installation, easy and instant access to the update software, higher productivity with immediate usage of software. So now let's take a look at the design management process. So in this, the first step is to save the CAD geometry to the 3D Experience platform. There is no import or export of CAD data in this. So we'll see about how the way it will function. The creating the CAD and this geometry will be imported here, and then it is uploaded to the 3D Experience cloud. So the access by the team members in the fashion of exploring the data, and it will be accessible at anywhere, at any time, on any machine where SolidWorks and SIMULIA apps are installed. Once the files are uploaded, we will open the geometry in the SIMULIA app and start the simulation. This is the licensing part, what we are talking. Let's take a look how to log in with the dashboard, cloud dashboard, and click on the compass for searching the SolidWorks app and launch the app, open the SolidWorks geometry, how it will be processed. So all the details over here. So first you want to log on to this. So here it will be processed with the launching app SolidWorks. So we'll be using this ARM like ASM Boom 14 model, and it is a local geometry in SolidWorks. Yeah, just open with the SolidWorks, and then we'll move on to this process. So whatever you are seeing in the right side pan, the task pan, which will be having a conversion with the 3D Experience to the always on. So you can save it as a format. Directly you can save this, and this file data will be saved in the cloud once it's done. You can see that green color check mark will be there, and which has been convert status is there, and then reserved geometry will be open up in the SolidWorks geometry, will be taken care in this 3D Experience cloud. So these are the methods of how to open this format, and we are not doing any import and export on this process. It's just a saving options. We are giving an options towards this. So these are the simulation steps. We are further process. So we want to see that how it has been seamlessly transferred in between this, and it will be having experience and synchronized model and simulation process. In this design validation, we can see that how the product engineer will work on this, and then modeling of this part, and what are the creating materials, meshing, connections, and then scenario creations. What are the loads you want to create? So you can see that update, whatever it is done in the steps, and what kind of loads you want to do, and how you are going to be restrained with this. And the most important thing with the review of the results. So in scenario creations, we will be creating that explicit dynamic steps, contact, loads, and outputs, and then how we can see about the history plots, engineering rules, and capturing the data for this. And it will be helping for you to know that industry specific, know how you can use it. And mainly this product will be used in the SSU as a module where you can see this, how it will be functioning. First, we apply the material, and then we'll go one by one with this. So we decide that we simply select the material and then palette is that applying the material in the component assembly. And next we create a mesh rule. This will allow the mesh settings and store the settings in the cloud database. Here we create a mesh rule tetrahedron, and then great way it will show you that. So how we will take it to the next materials, like you have multiple components, close to 100 plus materials or the parts will be available in the model. So that time it will be a great feature which can help you for this process. So you can create one time as a meshing editor, and then it will be applied to this next rule based. So this rule based meshing is a technique which helps you a lot and saving time when you do an analysis. So these are the process we will be going through this, how it has been engineered, document with this, and this rule applied to all the parts. So once I click it over there, this procedure will be applied. So rule based tetrahedron. So directly it will take you through this. So once I select this, and you can give it okay. So apply the same inputs to all. Then run. You can see that this helps you a lot of time in doing a meshing as a one by one process, or it is in the traditional way of process. It's different from this. So once you select this and set up a rule, then automatically it gets meshing with the same sizes what you are expecting, and it is a uniformed mesh. So that is also a great time saver for you in the process. And this you can see that boom orientation, and you want to save the design back into the 3DX platform, and guess that the mesh automatically updates with the new orientation also. So the geometry as well, it will be getting this update. So this is how it solves for us, and you can save it in the 3D model, right? So next we'll be checking for the another process like creating a virtual bolt connections on the bracket holes. First we will define that connections setting on one of the holes, and then we'll replicate the bolt connection setting to the other holes using the bolt replication tool. This is very powerful in avoiding the redundant definitions, thus saving a lot of time. So after that we will create options for the translators and connectors, how the load will be transferred with the rigid connectors, and then pin connectors. There are different connectors we'll be utilizing, but in this first we'll select about the virtual board connections. So I am just selecting one of the faces, and then it has taken as a rigid form. So we can update the mesh. So the bolt replication tool will help you a lot of things over here. Just selecting what are the dimensions available with the same sizes of holes will be selected over there. Automatically it is getting updated, and the moment it comes in picture, then you can select the way. So and just say okay. And this is a translator connector where it will be helping you on this process, connecting between these two holes towards that boom connectors. Specifically, you will be having with hydraulic connections over here, like a piston assembly. Instead of that, we consider that has been rigid condition to find out the load transfer, how it is going to be loaded on this knuckle joint and between this connector. So I'm giving an elastic set value, and then what are the damping available for this connections. So since it is a steel material, we will considering as a 0.02, and then we are giving an update for this machine. So the moment it done, again we can connect it for one more part. So you can create a coupling for this phases where the load has been transferred. The boom endpoint will be at a different location. This is the connecting point. So I want to select this phase, and then I want to set up the point load has to be transferred on somewhere with the another plane, maybe some 300 mm, 400 mm away from this point. So then also I can use this option. So this is the connection manager. You can see that what are the different connections you are using and what are the couplings you have been done for this process. So that has been taken care on this process. Once it's done, then we'll move into this creating the static analysis type and specifically the solver run properties, where will we define contact properties to specify friction values. Using the contact definition, here you can see that detection tool, how the phase pairs are touching inside this internally, and then we can have this forces one by one. So here I'll be take up to the physics scenario, what it is. So once you given that, you need to give a name and then selecting the FEM over there. This is a static step to solve it. So this is including geometry nonlinearity, initial time increment to most probably we'll be using with 0.1 seconds to solve it for 1 second actually. So what are the contact properties you want to give? That can be mentioned here. And if it is a sliding value, so we want to give it for the tangential behavior, and the frictional coefficient between the surfaces will be the 0.1. So these are the major things we'll be updating over here. And what are the surface contacts you can see here that can be listed out, and you can apply the surfaces. We will have a look so how it is being selected, and then tie the surfaces together by using a coefficient of friction 0.1. So this enhance that what are the contacts that has been defined in this process has been selected over there. And finally, we given the restraints for this, where to fix it. That's a process. And you can visualize that what are the connections you have given, how it has been translated, and what are the forces you want to give. Here at the tip of the boom, we will be giving a load by using that coupling point. So it will be around 9,800. Yeah. So I want to duplicate these cases for the next analysis purposes instead of creating all the things together for a long way. So here I can select it and use that. If that rotate about another 0 degree or different directions of load, that can be done. So this will help you that the boom will be extending at the same position, like it will be extending and again retracting. If it is working in the same position, what will happen? So that's how they given, and we'll giving for the fatigue type of loading, where we can see that lost increment values, how it has been signalized for these values. So instead of giving an SN curve conditions directly, here we are giving with superposition modeling. So by using the signals of 0, 1. So here we'll run for the model and the simulation check will be done. It shows okay, then we can solve it for in the cloud. You can see that there is a location, it is in the cloud, and then it's solved for you. So what are the cases? We have two types of cases, like non-linear static and axial loading, and then it will take into the superposition durability. So this will give you the results. The next form. So the main KPI we have to review that one misses stress and the log of lives. So the log of life values is nothing but about the fatigue, what we are talking on the durability point. And this location of maximum stress and investigating this is more response plot at the location. So when next we look into the fatigue results to minimize that log life in the assembly. So here you can see that value. So the maximum and minimum of stresses points. So the displacement is close to 8.2, the maximum displacement. And then log of life, it talks about the durability. It's 5.8, the minimum value. So we need to create a sensor over here to find out log life repeats, or specifically on minimum component. So once you showcase that, you can find that value of this minimum also. And we need to parameterize some of the options like yield strength and fatigue, but we need to see about the desired application. So what we are requested for this and where we are end up. So mainly it will talk about the next details. Mainly we'll verify about that whatever the life it has flagged as invalid. So we'll see that where it has been transferred. So here to see the requirement. So their expectation is log life. So actual is 5.86, but required is 7. So this is what their requirement. And the stress supposed to be less than 250 MPa. So that is also crossing the levels. So these two, I need to arrest it. Now it is actually close to 375. So these two, we need to address it. So what we can go ahead. So here, looking that designer can make those changes at the basic level, but we need to do that. The designer task has been changing with the design main boom assembly. So it's not an easy part, but we need to obviously go through the simulation. For that purpose, we are using that designer role, which has been empowered with this. So the assembly level, it has been changed now to the sub-assembly. When you see that design changes, it has been taken with what are the thickness we need to play. And simulation or non-experts can also use this guided assistant panel, which help you to solve this. And what we got the results, which is shown in the initial design, and we would like to modify the design with the thickness from 8 mm to the 12.7, which has been shown in the right. So this is what the modified design. Let's take a look how this works. So this by using SolidWorks, the designer role, it's adding an equation to the parameter for some of the design, especially we can use it for the options like small changes. But again, here you want to create equations. So I just selected assembly from this window and open with that. Can directly take it to the SolidWorks. Again, I will be editing this boom point. So by using the sketches values, I will create equations. So I want to add and edit the equations over here. So that dimensions can be a parametric. I can make it a change. So not only on this, and I will add the fillets also. So once I get an update, and again, I will be throwing this option over the 3D experience. You can see that there is a differences with the color coding. So changes, updating, all these things are there. So once you get it reserve, and then you can save it for the option. So directly take it to the 3D experience platform, and then you can using that physics simulation with the retractable boom. So this is the assistant panel where you can see that what are the contributing parts you required. So my concern is only on the boom part. So I'm just selecting on that part. Only 2 of 3 elements will be available for this. So directly doing a mesh and creating a bonded contacts on this. Like what are the contacts surfacing, it is there bonded, and say okay. And there is a restraint which will be clamping over here, the back surface of this boom. And front face will be having the plain restraints over here. Again, it will be taken as a remote load, giving a values towards this. So this is the plane. I'm selecting over that, and then we can give it. So once it done, then we'll go for the simulate option. So directly it will take you to the next level. So what results it will give you by using the cloud options, you can solve it through the cloud. So the review can be done. Earlier it was 8 mm displacement. Now let's see about the stress point. It is close to 87. Okay, we'll see that, and we'll see about that displacement also over here. So displacement talks about 3.2, which is more reliable answer where we are looking for. Then we'll see that what are the parametric bridging can be done for this equation. So that value you want to check it, right? So here I can give you for the value, and there is a parametric bridge. Just want to showcase that relations, how it has been taken care of this values over the SolidWorks towards here. That's 8 mm is drastically changed with 12.7, and solving is done for this model. Once you update, it automatically gets solved. And again, I want to give a simulate option. There is no need of changing that load or boundary conditions in this time. So once you update, then it will be taken through the results. So this is what you are seeing now. So that is 3.2. The component design is more stiffer now when you see that. So once it's done, then it will go for the approval process. So in this feature, we want to talk about specifically on this values, what it has given. So the designer requirements has been solved in this. After a new design change is approved, the simulation engineer will update the boom assembly, where you can update the version of this, and it has been done analysis through this. And previous design are not overwritten, but it is preserved to be used for later. This is a side-by-side comparison. We'll discuss that also on this modification point. So modified can and it can be resolved for you. We'll be running that boom thickness and stress checks also we can see from this. So we will be comparing the results with the two different studies which has been designed as a baseline, and second one is talking about the modified design. So we'll see that results it close to 8.2 and this is for 7.2. So the major attempt is realistically we see about the stresses close to 231. It is 325. But in the modified design, you can see that it is 231. So this graph is very important. When you see about this, we can find out that value which is lesser than this, and the stress is limited. Here it has been crossed the boundary. But when we see that this design, we take into the next level, and there is no any marks over here for particularly or weak region what we are seeing now. So this has been completed with that comparison chart with this. And one final thing, we want to do a requirement check how the KPI stands now or design requirements. So the actual required is same, close to 7, and the required is 250 MPa in the stress values, but we reached with the 225. So this is how it takes to the next level on the improvement part, and the fatigue life of the entire boom assembly itself. This is a great news for this assembly where we can get it through this value, and both of these both KPIs now exit the product performance expectation also, and the stress value is very low when compared to that what we heard with 8mm. Now it has been drastically reduced, and this is a resume journey we want to showcase on this. So the end-to-end modeling, and then that's taken to the key ways in the modeling and the simulation. The key ways in the technical point of view is about the structural mechanics engineer role, which can be helpful for you in this portfolio to create this simulation. And it allows for the simulation driven process. It provides that perfect environment for you executing the ModSim workflow. And together, the cloud computing and storages, they provide the unified modeling and simulation for you. And you can streamline the process of this, and modeling and the simulation only helps that accelerate innovations, improve product performance and the quality, ensure the functional efficiency also with this. So to forward this again, the second business of benefits is innovative product portfolio is a result of enhanced collaboration and the breaking down the silos between the teams, and it will be taking to the simulation upfront in the design cycle, which can shorten your market time and mitigating downstream risk and reducing the IT cost through the enabled cloud enabled simulation. It's a huge value that 3D Experience platform brings to the table, and reduced warranty cost and recalls and enhanced brand value is the realized benefit of incorporating the simulation early in the design process to predict the product performances. So to sum up with this, SIMULIA structural roles in the 3D Experience Works portfolio, SOLIDWORKS users can leverage simulation-driven design approaches to accelerate product innovation while beating most of the engineering challenges. A solution for upfront simulation-driven design with CAD and CAE associativity, guided user experience to accelerate the product innovation, and comprehensive set of advanced simulation capabilities for accurate and realistic design validation, and multi-physics capabilities for coupled physics domains, and reducing that IT infrastructure cost on the cloud computing capabilities for computationally expensive simulations, scalable and deployable across all skill levels like a product development stages, model size, and complexity. So these are the major thing we are looking into this. So if you have any questions, please open up. Yeah, I got an QA here with so whether this simulation in SolidWorks is compared to simulation in ANSYS. So the way what we are seeing is the comparison between the software to software is not a matter. So everybody is using the same type of equations. So how it is accessible to you and what way you can get the result. So that is more important. And what are the elements you want to choose it. Specifically from SolidWorks also we use from TET elements and other things. Now in this Abacus, what we are seeing with the 3D Experience platform, here we can use hexahedral elements, and whatever the core elements we are using with other products, not only in ANSYS, any products, we can compare with that. So the only thing is what workflow you want to go. As a designer, you want to design it and you can check for the next level. So that's how it has been modified. And this is a modeling plus simulation. That's how we mentioned as a ModSim. So I hope I have given an answer for you. If you have anything, we can connect again also. Fine. If you have any other clarifications or doubts regarding this simulation or this platform, how it's functioning, you can contact us through marketing@simtek.in. You can see that mail in the screen.
Team, it's been a wonderful session. Very thank you for everyone who joined the session and weren't there. So it's been a great. I totally believe it would be a great session for you guys too. So I just want to conclude this meeting with one insight. Okay, so if you guys want to know even more about SolidWorks, I encourage you to check our website. So it is simtek.in. You can search us. It's very easy. So please come to us. Okay, so you can see uh, all the products that which we are selling, and what are the products in SolidWorks, and what are the cloud products available, what are the services we are into, and what are the certifications. If you are a beginner, or if you are want to pursue any certifications, whatever kind of things, if you know any people who are interested to do certifications, anything, we can help on that front. And also we have a resource tab, so you guys, you can check this out. You have multiple amount of blogs, and ample amount of blogs and simulations in any area: design, manufacturing, sales, marketing. So, and also in 2D also we have blogs for that, and we also have the product brochures and white papers for that. Anytime you are welcome to check all the products we do have for you. It acts like a library. Whatever part, if you want to look for simulation, you can go and check the white papers available in our website. And also, if you want to check your system requirements for the SolidWorks software usage, you are welcome to check through the system requirements. It will definitely show the system requirements which is needed for the particular software. And also, we love to we invite you to check for the events page. We have multiple events happening in this quarter. There are seminars and webinars happening, and sometimes we will be also be part of some trade shows. We'll mention that here. So you're totally welcome to check this out. And we have upcoming webinars for on the month of May and June. You're welcome to register here. It's for free totally. And we do currently have some great offers going on. You can check our offers also here. So thank you once again, guys. I hope the session will be a great insight to you, and we will catch up soon in the next webinar. Have a good day. Bye.